Alright, so we've already talked about how to build a two-channel wire that will allow us to extend it with this wire traveling in one direction. So for example, moving from west to east, we used two cells sitting side by side, and a series of these constructed what we called the program channel and the control channel. The program channel is mainly used to pass data and to route a configuration request from the control channel into the C input of a target cell. And I'm going to draw these bidirectional for today. And the control channel routes the C information, but with a slight twist. Instead of just taking the information coming from the west and passing it directly to the east and the north, we make a selection using a little bit of logic. So if there is no cell sitting to the east here, we'll have a 0 coming in, and that will get inverted to a 1 ANDed with CC, and the CC signal will get sent to the north, which will turn the D signal into a C signal on the target cell's western edge, and that lets us control both the C and D input of this target cell. But if there is a head cell sitting here, it asserts a 1 to its southern D output, and the head CC cell, the non-head CC cell, will take that and route that to the west. And so any cells downstream will receive a 1 coming in on this line, which will get inverted to a 0, which will block the CC signal from moving up here. And so this cell will no longer be configuring the cell to its east. And so this feedback signal, this 1, is what moves the head of the wire. In the case where we have a 1 coming in, we instead want to take the control channel signal and just keep passing it downstream. And so we just AND that east and west and send that out. So this is what our extendable two-channel wire looks like, and that works fine, and we can do a pre-clear sequence to move through stuff that's already been configured. The next question, though, is how do we turn this wire? Suppose we want to start moving from this direction into this direction. We need to make a corner, and a corner circuit is pretty simple. It takes 4 cells in a 2x2 arrangement. And when we're done, this will be the new program channel, and this will be the new control channel. And the operation of this circuit is pretty straightforward. Now remember, when we're building this, this is the actual target circuit. This is a circuit we get direct control over. So we're going to change this cell to just route program channel information. It will get routed through a corner here, and it will eventually pop out the southern D output of the new program channel head cell. So the D path is pretty straightforward. The control channel path, not too much more difficult. Again, we take data coming in from the west and we send it to the control input on the south. So this will be our new target cell down here, as usual, at the end of the program channel. This cell is where the interesting stuff happens. So we need to do 2 things. One, we need to manage the control channel signal that's being transmitted. So control channel comes in here, and when we start extending this wire to the south, remember, we're going to have a 1 coming out here and a feedback going like this. So we're going to ultimately have a signal here coming into the southern D input, which says whether we want to treat these as head cells or not. So just as in the case of our regular west to east wire, we need to take the data coming from the south and use that to decide how we're going to treat the control channel. So if the control channel is a 1, and if we don't have a feedback signal coming in, that will generate our control signal going into our target cell. But if in fact we do have a feedback signal, then we're just going to pass the control channel information straight down to the south. And ultimately, again, this cell, which is our new target cell, will be configured with this 1 bit coming to the south, and this CC new head cell will take that 1 and route it to the north, and that will move the head cells from here to here. To build this circuit, though, we need to move the head cells from here to here. And in order to do that, we need to turn off this C output that's going in to configure this. And remember, the way to do that is to send a 1 into this CC head cell's eastern D input. And the whole trick was, once you configure a cell, once you change this cell, once you move the head, you no longer have control over those old target cells. So the last thing we do has to be the thing that actually moves this. And so this actually looks exactly like the way we've been moving the head on the west-east wire. We have a data route from north to west, and the last thing we configure in the old target cell is a 1 going to the south. So there is our complete corner structure. And if we configure these 4 cells with these 4 configurations, with this being the last cell we configure, in particular with this 1 going to the south, the next time that we assert the CC signal, instead of trying to configure this cell's C input will be asserted, and the PC line will assert its D input. And so we'll move from being able to configure this cell to having this be the new target cell that we can configure. That's the basic setup, and to build this circuit is pretty straightforward with one small wrinkle. We can configure this cell directly. We know how to do that. We can configure this cell directly using this. That's how we do our regular 2-channel wire. And instead of building off access, we can use this cell to configure this cell, and that's very straightforward. But this remote corner cell takes a little bit of finagling to actually get it to configure in a reasonable way. And so the next lecture is going to talk about that as its own topic, because that's a really useful construct when you're trying to configure something that's more than 1 cell away from the target cell. So the subject of that will be doing OR configurations, and that will be the next video.